So greetings students, welcome to your lab 3. I'm Arif Shahriar and I'll be instructor of your today's lab. So the topic of today's lab is recursion. So in today's lab we have few tasks, and look at the first problem. We have to implement a recursive algorithm to find the factorial of a number n. So we'll be talking about the concepts of recursion. So in mathematics, how do you define factorial? Factorial is defined as a product of all the integers starting from 1 to n. Now that means we define the factorial of n as n multiplied by the previous term, which is again multiplied by the previous term, and up to the first term, which is 1. This is how we can express factorial in mathematics. So let's look at the partial segment of this expression. In the partial segment of this expression, we can see that here we have product of all the numbers starting from 1 to n minus 1, which itself can be written as the factorial as n minus 1. So this is how we can rewrite the whole expression. So n factorial can be expressed as n multiplied by the factorial of the previous term. So apart from this case, there could be an exception. So how can we calculate factorial? From the simplified expression, we can write that n factorial equal to n multiplied by n minus 1 factorial. This is the normal case when n has a value greater than 0. But what if the n has a value equal to 0? When n has a value equal to 0, then the factorial of n would be 1. So this is the exceptional case that I was talking about. We have to handle this case separately. This is why I've used this condition. When the value of n is equal to 0, we'll have to return 1 to the user. So when we write a function as a simple form of itself, this is called a recursive function. Here we have written the function factorial as a simple form of an expression which includes a factorial function. Okay, so this type of function is a recursive function. This concept is also valid for the concept of programming. We can implement this type of functions in programming too. Now let's write a function to calculate the factorial. So let's name the function. We're going to name the function as fact, since it's going to calculate the factorial of a given number. So what this function will return? This function would return an integer value. And after calculation, this would return the result, which would be an integer. So what parameter does this function take in? This function takes in the parameter an integer value, which is specified here as n. So here n could be a positive integer or n could be equal to 0. So what are the two cases that we're going to handle here? We're going to handle the exceptional case first. Then we're going to handle the general case. So to handle the exceptional case, let's see, when the value of n would be equal to 0, we would return 1 to the user. This is the exceptional case. And for the general case, I would keep this in an else block. So what we return to the user, I would return n multiplied by factorial of n. This is what we write. Here you can see I'm calling the function within the function. So when I'm calling the function within itself, this is basically called a recursive call. After that, I'll end the method body. So this is the function for calculating factorial of a number. Okay, so let's see how the program executes. Let's trace the code. So in order to keep track of the method calls, I have designed this table. So in this table, let's keep track of the first method call. When we call factorial, we pass an integer. Let's say we pass a value 4. Here 4 is an n, which is a positive integer. When we call factorial of 4, what happens in the first method call? In the first method call, it checks in the method body whether 4 is equal to 0. No, it's not equal to 0. So we move on to the else part. So what we do, we write it as an expression of 4 multiplied by the factorial of the previous term, which is 3 in that case. So in that case, the code execution pauses and this goes to the method call. So once we're done with the method call, we'll go back to this part. But let's look at the method call. This is the second method call. So here we're calculating the factorial of 3. So let's check whether 3 is equal to 0. No, 3 is not equal to 0. So we're going to express it as 3 multiplied by the factorial of the previous term, which is 2. So here the code execution pauses again and it goes to the next method call. Okay, so we go to the next method call where we calculate the factorial of 2. Here we check again. The value of 2 is not equal to 0, so we move on to the else part, which is the general case. So in that case, 2 is multiplied by factorial of 1. Okay, so now it again pauses the program execution and it will go to this method call. In this method call, what we do, we calculate the factorial of number 1. So let's check. Here 1 is not equal to 0. So here we also go to the next else part. In the else part, we can write it as expression of 1 multiplied by the factorial of previous term, which is 0. So here we again pause the execution and we go to the next method call. Okay, in this very last case, let's look. Here we have passed 0 as the value. So yeah, 0 is equal to 0. So what we return? We return 1 to the user. So here what happens? We return the value of 1 to the user. Okay, 1 gets multiplied to 1. We calculate the value of 1 and here it goes back to the method which called it. And here we calculate 2 multiplied by the 1 and we calculate the value 2. And again it returned to the method which called it. Okay, so it was paused as I told you earlier. Now when it gets back the value, it resumes its execution. The 3 gets multiplied to 2. We get a value of 6. Here the value is returned to the method which called it. Okay, so here the execution resumes again and 4 gets multiplied to the return value 6 and we get a resulting value of 24. So in that case, this is the corresponding result of factorial of 4. So this is how this program executes, and this is how the concept of recursion is implemented to calculate the factorial of a number. So let's look at the problem. Here a crucial case is that when we reached this call, when we reached to the call of factorial of 0 and we went to that specific case, and when the value of n became 0, it returned 1. So without this condition, the program would have continued forever. It would go on and on. So it would never pause execution. So to avoid this case, we need to make sure we implement a condition like this, and which would stop the method call. And this is the common mistake that you do in the recursion problems. We don't include a base case. So we always need to include a base case or a termination condition, which would make sure that the method call would stop, or else we will run out of the memory and the program execution will pause and we will get an error in that case. Okay, so now let's write a program to calculate the factorial of a number. So at first we prompt the user to enter a number. We prompt the user, enter a number. Okay, so we're going to take an input So we use the scanner class. We're going to specify the system standard input device here. So let's store it in a variable called num. We're going to take an integer as input, so use the nextInt method. So now let's write the method. So we would keep the method public, and we'd keep the method as static since we're going to call it from the static main method. What type of value would the method return? This would return an integer result, so we kept int as a return type. And let's name the method, which is fact, and it takes in a parameter which is n. So inside the method body, what we do, at first we check the exceptional case or the base case. If the value of n is equal to 0, if the value of n is equal to 0, we return 1. That's it. For the general cases, when the value of n is not equal to 0, what we need to return, we would write it as expression where n is multiplied by the factorial of the previous term. So this is what we write. So this is the code for calculating factorial. So we're going to print the result here. The factorial value is, let's call the method fact, and what do you pass here? We pass the number that the user has entered. So now let's call the method. So let's enter the value 4, since we checked for 4 and we traced for 4. So it returns that the factorial value is 24. Okay, so now we can trace the code further. So we can include some print statements to check the flow of the code, how the methods get called. At first, like we print, we're calculating factorial for what? For the parameter n. So after that, this else part is actually redundant here. So let's remove the else part. We indent the code. Okay. So instead of directly resulting the result, we're going to store it in a variable called result. We stored the factorial of the previous term, so we're going to print it to the user that finished the result is, and I print the result. Okay, so now instead of returning this one, we have already calculated the value of the factorial of the previous term, so we include this value result. So now let's call the method. So we're going to calculate for factorial of 4. Let's pass 4 here, and let's look at the console output. So what basically happens here, at first we pass 4 as the initial parameter, and here it pauses the execution, so it goes to calculate for 3, and then it again pauses the execution, it goes to calculate for 2, it again pauses the execution, goes to calculate for the factorial of 1, which in turn makes another method call which calculates the factorial of 0. So here we get the factorial of 0 is 1. So then once we get the factorial of 0, we get the factorial of 1. And once we get the factorial of 1, we can calculate the factorial of 2. And after getting the factorial of 2, we can easily get the factorial of 3, which is 6. And which in turn gives us the resulting value, the factorial of 24. So this is what happened here. Okay guys, let's look at the second task. So here we need to find out the nth Fibonacci number from a Fibonacci series. So we need to implement a recursive algorithm to do this. So at first, what is a Fibonacci series? Let's write a Fibonacci series here. If we include the numbers from the series, we can see the numbers are like that. after the first two terms, we can calculate the third term from the summation of the previous terms. So 0 plus 1 get added to 1. So after adding these two terms, 1 plus 1 we get 2. And after adding the two terms, 2 plus 1 we get 3. And adding 3 plus 2 we get 5. And adding 5 plus 3 we get 8. And this is how the series will go on. So let's number the elements of the series. This is the first, second, okay. So here we have 7 elements in the series. So how can you find a number from a Fibonacci series? So we can see, in order to find out the nth element, what we need to do, we need to perform a summation. So what we add up the previous two terms. If this is the nth element that we want to get, so we need to add the n minus 1th element with the n minus 2th element. This is how I get the nth element. So if I write this as a function, so let's write it as a function. I can write the function as f of n. How can you find out f of n? Let's consider the general case first. So this is the general case. I add up the previous two terms. Okay. Here f stands for Fibonacci. Okay. So when do we add up the previous two terms to get the current term? Well, let's notice, after getting the first two terms, we can add up them to get the next term. Then we can add up the next two terms to get the very next term. This is how we can repeat the process. But for the first two terms, we cannot retrieve them using any methods. For the first 0th term, we return simply 0. For the first one term, we return simply 1. So this means where if n indicates the number of term, from the 0th term I'm returning 0, from the first term I'm returning 1. So actually I'm returning the number of the term. I'm returning n for it. So what I do, I just simply return the value of n. So when I simply return the value of n for the first two terms, so when the value of n would be equal to 0, and when the value of n would be equal to 1. And after getting the first two terms, I can always add up the previous terms to get the next term. Like 0 plus 1 gets added to 1, and 1 plus 1 gets added to 2. This is how I can do that. So the general case is applicable when the value of n is greater than 1. When I'm trying to find out a term which is greater than one term, that means I'm going to find out the second, third, or the fourth term, and so on. So let's write a code to find out the nth term of a Fibonacci series. So before writing a code, let's write a pseudocode, a method in the pseudocode. Okay, so what I'm going to name it, let's name the method as I'm trying to find out the Fibo. Let's call it Fibo. I'll pass in an integer which is called n. Okay, so after passing this integer, what I check for? I check whether the value of n is equal to 0 or 1. That means I'm going to check whether the value of n is less or equal to 1. When the value of n is less or equal to 1, I simply return what? I simply return the nth term. And let's handle the general case. When the value of n is not equal to 0 or 1, which is greater than 0 and 1, I can return the sum of the previous two terms. So this is the else case. So what do I return in the else case? I return the terms which are in the Fibonacci series. So here I need to call the Fibonacci function so that I can find out the value of the element that I'm looking for. Here I'm looking for the previous two elements. That means the element n minus 1th element and the n minus 2th element from the Fibonacci series. Since I want to find out the two elements from the Fibonacci series, so I'm passing them through the Fibonacci function. So this is the function. So this function is going to be implemented in the program. So before writing the program, let's trace for one of the values. Let's say I want to find out the value of the fourth term, which is 3. This is what I need to find out. I want to find out the value of the fourth term. So here the value of n, which indicates the term that we're going to find out. We're going to find out the nth term, which will be the fourth term, for example. Okay. In order to find out the fourth term, we call the Fibonacci function. For simplicity, I'm just denoting it as f. Okay. So let's call it as f. At first, I make a call of f of 4. So after making a call of f of 4, so for f of 4, what I need to do, here I need to check whether the f of 4, here the value of n is less or equal to 1. No, it's not less or equal to 1. So what do I return? I return the previous two terms. That means I return f of n minus 1, which is 3, and f of n minus 2, which is 2. So which is not again equal, is less or equal to 1. So I would again go to the else part. So what I do, for the else part, I would return the previous two terms. So what are the values of the previous two terms? I would return f of 2 and f of 1. These are the terms that I'm going to calculate. So the program again pauses and it would call f of 2. For f of 2, it goes inside the program and it says whether the value of n is less or equal to 1. It's not less or equal to 1. So what it does, it pauses and it calls for the previous two terms. So what are the previous two terms here, which are basically n minus 1th term, means f of 1, and n minus 2th term, which is f of 0. These are the two terms that I'm going to calculate. Okay, so now after handling this part, this is basically called a recursion tree. So you can notice that I paused for f of 1 and f of 0 because in that case we have reached the base condition or the termination condition. In this case, the value of n is less or equal to 1. So for when the value of n is less or equal to 1, what I do, I simply return the value of n. Here I return 1 and here I return 0. And so what I was doing, I was adding up the two terms and return the summation to the function which calls it. The summation was 1. And here I also didn't write anything because here I also reached the base case when the value of n is equal to 1. So it is less or equal to 1, so I simply return the value of n, which is 1 in that case. So I add up these two terms, which would give me 1 plus 1, it would give me 2. And in that case, let's handle the right part of the recursion tree. So go to the right part, f of 2. Inside the method body, it checks whether the value of n is less or equal to 1. No, it's greater than 1. It's actually 2. So what do I return? I perform two method calls. So the two method calls are for the previous two terms. I search for the term f of 1 and I search for the term f of 0. So for f of 1 and f of 0, I have reached the base condition where the value of n in both of the cases are less or equal to 1. So I should simply return the value of n. Here the value of n is 1 and here the value of n is 0. So I need to add both of them. When I add both of them, I get 1. Okay, after getting 1, I would return them to the method or the function which called it. I would return the value of 1. So in that case, those two methods were called by f of 4. So those two methods results will be added up and the sum 2 plus 1 equal to 3. The sum would be returned to the method 3. So 3 in that case would be the result. That means the fourth term in the Fibonacci series should be 3. So let's check it from the series that we created. From the series, let's see, the value of the fourth term is 3. So here we got the proper result. So now we're going to write the code for Fibonacci series in our IDE. So now we're going to write a recursive algorithm to find out the nth Fibonacci number. So far I've completed a small segment of the code where what I did, I prompted the user to enter the value of n. Here n indicates the nth term, the number of term that I'm looking for. And after that the user has entered the value, which is an integer value. So let's write the rest of the code. So what I'm trying to do here, I'm trying to write the Fibonacci function. So the function would be static like the previous one, because I'm going to return the value to the main method. So I'll be calling this function from the static main method. And what kind of value I'm going to return? I'm going to return an integer value. So let's name the function. In our pseudocode we named it as Fibo. So I'll take an integer value as input, which indicates the number of term. Here n indicates the nth term. Okay, so now we're looking for two cases. Let's consider the base case first. When the value of n is less or equal to 1, what do? We simply return n. For 0 we return 0, and for 1 we return 1. This is what we do. For the general case, what we do, like the terms after 1 which are greater than 1, what do? I calculate the summation of the previous terms. So here I return the summation of the previous terms from the Fibonacci series. So here these two methods will return the two corresponding previous terms from the Fibonacci series. So this is the function that I've written to find out the nth term. Now let's print this out the print line. So what I'm going to print, the result is, or let's not write result, let's write the nth term. So that means I'm going to write the nth term of the series, of the Fibonacci series. What would be the nth term? I'd calculate it here, Fibo n. So we already traced it for the value of the fourth term. And what was the value of the fourth term? For the fourth term the value that we got was 3. So now let's check it in the program. So for the fourth term, so the fourth term of the Fibonacci series is 3. So this is what my program has printed. It has found out the fourth term of the Fibonacci series, and which was the term? In that case the term was 3. This is the resulting term. So now let's look at the third problem. We're told to print all the elements of a given array recursively. So how do you do this? Let's see, how do you do this? Here I'm going to take a sample array. Let's say the sample array is named as RR, and here I name the indices of the array, which are 0, 1 and 2. These are the indices of the array. Let's insert some random values in them, like 10, 20 and 30. So what do I want to do in this method? So let's call this method a print array method. This method is just printing, so we don't need any return type. We can keep it void. So what do I pass inside the method? I pass the location of the array. Since I need the location to print the indices of the array, then I'm going to print an integer which will indicate the current index that I'm printing. Let's say the integer is x. So what do I need to check inside the method? At first I need to make sure that I have a base condition. so that the recursion doesn't goes on and on. So in order to stop the recursion, in order to stop the method call when we reach the last index, I set a base condition like when I reach the last index, that means the last index, this is the array length, this is my base condition, this is when the recursion would stop. So what do I keep inside this if block? I basically do nothing, I just specify that this is my base condition. So for all the other cases, what I want to do, for all the other cases I want to print the array element. So let's do a system.out.println statement. I print the current element of the array. Let's say the current element is in the index x, so I print the current index. Then what do I do? Then I increment the index by 1, so I do a post increment x++. Then until I reach the last element, I make sure that I call the print array method. So here I'm making a recursive call, I'm calling the print array method, I'm passing the reference of the array, and I'm also passing the current index that I'm printing. Okay, so this is basically the method to print an array. So now let's keep the method aside and we're going to trace the method. So we're now tracing the method. At first we're inside the main method. So this is my main method. Inside the main method I give a method call. So here for simplicity I'm calling the print array method as PA. Okay, so and for simplicity I'm calling the name of the array as A, just simple A, and I have to pass the starting index. So what's the value of the starting index? I want to print from 0, so the value of the starting index is 0. So now we go to a method call, and what happens inside the method call? Let's look at it. Inside the method call, at first we have passed what? We have passed the reference of the array and the current index that we're in. We're currently at index 0. So what do? I check in the if block whether the value of the current index has reached the end of the array. So the end of the array is specified, the array length is specified by 2, whether I have reached the index 2 or not. No, I haven't reached the index 2, so I go to the else part. Inside the else part, what I print the current index value. So the current index value for index 0 is 10, so I print it. After that, what I increment the value of the index. Let's say the value of the index was 0, so I increment it to 1. So I do then what? I do another method call, and I call the print array method. I do a recursive call, I pass the reference of the array, and I pass the current index. So what happens inside this method call? So let's go inside the method call. Inside the method call, what I have passed the reference of the array, which is A, and the current index, the value of x, which is currently 1. So now I do what? I print the value of the current index. So what is the value of index 1? I simply print 20. And then what do? And then I increment the value of x. The current value of x is 1, so I increment it by 1, so it becomes 2. So now what do? I do the print array method inside the else block. So what do I pass? I pass the reference of the array and the current index. Okay. So now it goes to another method call. So what happens inside this method call? Let's see. I have passed the value of the reference of the array and the current index that I'm at. I'm the current index at 2. First I check whether I have reached the array length. The array length would be 2 plus 1, the array length would be 3, since I have 3 elements in the array. So I checked whether I have reached the array length. No, I haven't reached the array length yet, so I go to the else block. At first I print the value at index 2. So the value at index 2 is what? The value at index 2 is 30. I print the value 30, and then what I do, I increment the value of x. The current value of x is 2, and I increment it by 1, so it becomes 3. I again call the print array method. I pass the reference of the array and the current index. So inside this method call, I go and I check to the if block, whether I have reached the end of the array. Yes, I have reached the array length. I have reached 3. So the base case is filled up. So when the base case fulfills, what I do, I simply return. Since the return type is void here, I simply return to the method which calls it. In that case, it was called by this method, and this method returns a void to this method, and this method in turn returns a void, and this also returns a void. So this is how we trace this code. So now let's implement the program. What I'm going to do, at first I'm going to have an array. So I'm going to have the array that we did. It contains 10, 20 and 30 with a length of 3. So after declaring the array, I'm going to call the print array method. So let's write the print array method. It's a static method. Since I'm calling it from the main static method, it returns nothing since we're printing. This is a void type. So then what do I name the method? I name the method print array. What does it take? It takes the reference of the array and it takes the current index that I'm in. So now at first I'm going to write the base condition. What is the base condition? If the current index value is equal the length of the array, so I have reached the base condition. I basically do nothing. So let's say this is my base condition. So if I haven't reached the base condition, what do I have to do? I have to print the value at the current index. So I do a system.out.println and I print the value at the current index. So array x, this is what I print. So after printing the value of the current index, I need to increment the index by 1. This is what I do. And after that I recursively call the print array method. So what do I pass inside the print array method? The reference of the array and the current index. This is what I do. This is now I'm going to call the method. The print array method is going to be called here. So at first I pass the reference, and now I'm going to pass the index from which I'll start printing. In that case I want to print the whole array, so I refer the first index. Then let's just compile the code and let's see. It prints all the elements in the array. So I hope you can implement the rest of the codes by yourselves. So this is all from me. So thank you people for watching.